Hello everyone, it's December the 4th. Alright, so the goal, we will first do this, right? And after do the challenge, we're gonna go back here. I mean, we solved it yesterday, but it's necessary to go again, just to, analyze the whole thing again. It'll be helpful. It'll be very helpful. Alright, first things first. Oh, one more thing. My cough is getting better. Like seriously, I'm not coughing right now, and feeling better too. The training in the morning was the best in quite a while. I mean, feel very powerful, very fast. I mean, on the video, it didn't really look fast, but when I was lifting, I can feel it. I mean, I can feel the difference. So that's that. Anyway, middle of the linked list, giving head to the middle node of a linked list. If there are two middle nodes, the second. Oh, so it's a tortoise and hare, right? Depends. I think we should start from the start, right? So you go boom, one time, two time, boom. So two time, 1, 2. Okay, 1, 2, 3. Okay, count 3. So go 1, 2, 3. So what is that? So I have to go one more time, which means if it's next, then we need to do something like I don't know. Something like head, not slow and fast. We can both become head. And while fast on next. Fast equals fast on next. If fast on next. Fast equals fast on next. And then slow equals slow on next. Then we return slow. Something like this. Let's see if it works. Test case will be whatever test case we're gonna have, and edge case. That's about even, odd edge case. Maybe we should go 2 as well. You know what? That's a good point. We should go 2. 1, 2, 3. 1, 2, 3, 4. All right. Cover all the cases. Yep. Okay, that's that. 885. Good. Very good. This is a good question. What do I want to say? I want to say tortoise and hare. All right, so now let's go back to this problem. So what we want to find is a palindrome of length 5, right? And we have all our schemes trying to do this, but it didn't work. Right? It didn't work because we're trying to say, okay, we'll find all the indices that corresponds to 1 digit, right? And then for every 2 of those digits, and then we'll find all the 3 palindrome in between. It's convoluted. As I was thinking about it, I was like, nah, that doesn't seem right. So what is right is we will use the middle. That's actually a good one because if we can find all the palindromes with this middle at the current spot, and that's all of them. So we just go one by one. So the question is converted to finding all the palindromes, all the 5 palindrome with the middle, right? With the center determined. And then that's one. But this is very important. to understand that it's a 5 palindrome and there are only 100 possibilities on the left and correspondingly on the right. So it's only 100 possibilities. So what you need to do now is to find the counts of all possible combinations, right? The counts of each 2-character by 2-digit combinations on the left, right? And the total count of all the 2-digit combinations on the right. And that's it. And as the middle one move to the right, we will increment on the left and decrement on the right. And of course, when we actually implement it, the way I implement it is from right to left. So it's the left going to decrement, the right going to increment. But it's the same, right? It's the same. Okay, so now we have reduced the question to finding the total count, the counts of all the 2-digit combinations, right? Say on the left, and 2-digit combinations on the right. And the way that we usually do this type of problem is we will dynamically change. So all we need to do is to find, in my case, to find all the 2-digit counts from left to right, all the way to the most right we can go. And we have analyzed that the most right we can go is n minus 4, right? N minus 4 is the index that the most right we need to go. So from 0 to n minus 4, we need to find the total number of the counts of all possible 2-digit combinations, 2 digits. So we call it left to right, double-digit count, right? And to find that, because it's not sub-array, it's subsequence, right? It's subsequence. So the way that we can make this count easier is for each new digit encountered, right? All the previous digits, they can all pair with it, right? So if the current digit is a 3, and the previous we have 0, 1, and 2, then the 0 can pair with 3, 1 can pair with 3, and 2 can pair with 3. And the total number of such pairings is the total number of occurrences of digit 0, digit 1, and digit 2. So we need to keep track of the left to right single digit count, right? So we have the single digit count. Now we encounter a new digit. So we'll go through every digit from the single digit count, and each of them can pair with a new one. And then that will be the additional counts for that double digit pattern. And then we add that to the double digit count. So basically this is what we do, right? So we're gonna go from the start all the way to the most right we can go. And for each one of them, we're gonna go through the single digit count, right? The key and the value, the single digit count. And the double digit count, we will add to, the key, which is the single digit count what we have, the left digit, and the current digit, we put them together. So that is the current double digit count, and we'll increment by v, which is the total number of the counts of the single digit. And then we go through all of them, we update the double digit count, right? And after we've done that, we increment the single digit count. Boom. So that's how we do the left to right, right? We have the total. And then we have to also have the right side. I mean, on the right side, for the start, because we have to have 5, so the center must be -3, or you can say n minus 4. No, n minus 3, right? N minus 3. That's what we need to do. So we only have 2 digits on the right, so we can do the single digit count and double digit count very easily like this. So now when that is done, then we can do, right? So what we do is we're going to start n minus 3, right? That's the rightmost center we can go, and we're going to go one by one all the way going to, we go 1, so the last index we're going to take is 2, right? Because 0, 1 will be on the left side. So for each of them, we basically just go through. This I have a little bit of trick here. I only go through the smaller of the two. We can just go through one of them, but this will be slightly faster. We'll go through the smaller, go through all of them, all the double digits, right? So all the double digits, either on the left or right, doesn't matter. So for each of them, we want to find the total number of counts on the left, right? Here is right, and I want to find its palindrome, which is just the reverse, right, on the other side. And then when we find all of them and they can pair, they can, one pair with everything. So it's going to be the multiplication of these two. So we multiply them, added the rest. And if the sides switched, then we're going to swap. So there's no problem. Now the key is here. We need to update, right? Because after we're done with this J need to move to the left, right? Need to move to the left. So before we move to the left to right, single and double digit count need to remove J minus 1. Because the next center digit is going to be J minus 1, Sj minus 1. So we have to remove it before we move there. So to remove it, I say, okay, I'm going to go single digit count. We'll remove that first. And then this is just additional, just to make things a little bit easier. So I will add this. Now we're going to handle the double digit count, right? So basically we say Sj minus 1 need to be removed. So everything that pair with it need to be removed, right? So for the single digit count, every one of them before reaching the current one. So that's why I do this first, because this is reaching J minus 1. So I remove it just before reaching J minus 1. I have all of the digits, right? Digit count, K and V. So all of the V need to be removed from the pattern. So that's what we do, right? So it's the K plus this. So this, because I remove J minus 1, so this pattern needs to be removed. So I remove minus equal to V. And I do this because I also do this. So yeah, that's that. Yeah, so this is to remove. And on the other hand, we need to add, because for the right side, right, the right to left double digit count, we need to add it. We need to add the impact of Sj, the current one, add into it. But now it's very important to know here that when we add, it has to be Sj plus K instead of K plus Sj, because the palindrome, when we consider, is still going to be left to right, right? So this is on the right side. The single digit count is on the right side. Now we add Sj. So we add up starting, right? The starting digit of the pattern. And for the starting digit of pattern, I can have V number of K digit, right? The K, that digit in the remainder. So everyone can be paired. So the Sj can be paired with all these Ks, right? So this is be the new pattern, and then we add V, right? And then we do this, and then we done with everything, and then we return. And of course, yesterday we made a mistake. We made a mistake because we forgot to mod. But now we mod, everything is fine. Counting prefixes and suffixes. Yeah, we know how this one's done. Do you want to write something? Yeah, I didn't write yesterday. Now we're gonna write. So the two hints are very important, right? So the second hint, right? The second hint points out that we should consider each middle digit when constructing the length 5 palindrome. And once the middle digit is set, we need 2 on the left and 2 on the right. Now the first hint points out that the 2-digit pattern on the left and right, on the left, has no more than 100 possibilities, right? Possibilities. This means in the worst case, we can iterate through all the patterns, right? Find its count and find its reverses count on the right side, then we will have the total count of length 5 palindromes with the current digit at its center. So the problem now has converted to how to compute the counts, right? The counts of all possible, not all possible, just counts of all double digit pattern, right? From left on the left side, I just say on the left and on the right. Now this we can use DP to solve this. Each time a new digit is encountered on the left side, each time a new digit is encountered, we all the digits that have been encountered before can pair with the new digit to form a double digit pattern. Now the total number of such pattern for each previous digit is equal to the count of that particular previous digit. Thus, we just need to keep track of the count of single digit, right? And then with each new digit encountered, we can obtain the additional count of double digit given all the single digit count previously. I'm not sure if it makes sense, but if you read the code, it makes sense. Similarly, we can do the same on the right by going from right to left, right? Then with each newly encountered digit, we can find double digit pattern starting from the new digit and ending in one of the digits that have been encountered before. Now we can pre-compute the left double single and double digit counter, the left and right, and then as the middle digit move, we modify the counters as we go. And that's it. That's how it is done. What's the runtime? Oh, these are all ON. I beg your pardon. These are not ON. This is ON. What is this? That seems ON to me as well. Oh no, that's 10. So O10N. So yeah, O10N. Oh. You want to post this? Well, don't think it's necessary. 100 n. I don't think mine is 100 n. It doesn't matter. You solved it, and when you see the hints, yeah, I kind of want to post it. I should read it again, see if it. We need 2 on the left and 2 on the right. In the worst case, we can iterate, right, through all the patterns, find its count on the left, and find its reverses count on the right. Then we just need to multiply the 2 counts, right? And we have the total number of lengths 5 palindrome, length 5 palindrome. At the current middle digit. All right. So how to compute the counts of all double digits on the left and on the right. STB solve this. On the left side, each time a new digit is encountered, all the digits that have been encountered before compare with the new digit to form a double digit pattern. Total number of each pattern, right? Total number of all the digits to form additional double digit patterns. Total number of such additional double digit patterns is equal to, is equal to the count of the previous digit, equal to the count of the previous digit. Thus, if we keep track of the count of single digit up to the current, we can easily produce, right, compute the counts of all possible double digit pattern, ending double digit pattern up to the newly encountered digit, right? Similarly, we can do the same on the right by going from right to left. The only difference is that the additional right? The additional double-digit patterns are formed with the newly encountered digit as at the beginning. I'm doing LeetCode. It look great, let's see. Additional double-digit counter are formed with a newly encountered digit at the beginning instead of at the end, as in the situation on the left. Does that make sense? At the beginning. Yeah, that will be it. There we go. Okay, let's post this. I mean, this is not a 4D. This is just double digit pattern. ON. Well, I think that's O10N. Alright, because this is... Oh, hold on. O100N. Yeah, O100N. Because this is 100. O100N. Count double-digit patterns. That's dynamic programming. I don't know. Is it top down or not sure? How would you call it? But that's called length 5. That's how we call it. And we don't need this. Let's remove this. Putting it here. Very useful. I shouldn't say important. I mean, what we can do is just go with it. Hold on. A bit less optimized. All right. But it will be easier. Which is now we don't check this. We always can go this. Okay. And then we don't delete. All right, look how simple. How much simpler it gets. Wait. Why is it not correct? Oh, that's interesting. Wait a second. That's not correct. What? 9, 28, and not, wait, what? Hold on. Something is not right. I didn't change. It's the same. Oh, dummy. Yeah. Okay, so this is the solution we want to submit. Oh, don't add this. Yeah, and it's not too bad. It's not too bad at all. It's actually better. Okay, now we can use this. Simpler, right? Much simpler. I said it's gonna be useful. Okay. That's it. All right, what do you want to do now? Well, let's go to the contest. Well, not go to the contest, just go to the last page. For fun. Let's just get all them out. Alright, let's set up a goal. So we are 32 minutes in, right? So we have half an hour. Let's solve 3 problems in half an hour. Let's see if we can do that. Oh man, this is going to be fun. Alright, circular sentence. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. For example, hello world, blah blah blah. They're all sentences. Words consist of only upper and lower case. Upper and lower case letters are considered different. Sentence is circular if the last character of a word is equal to the first character of the second next word. The last of the last word is equal to the first character of the first word. So LeetCode exercises sound delightful. Oh, okay. Oh, we can go we can go to single. Nice. LeetCode eats soul. Nice. Good. It's very self-aware, huh? Alright, LeetCode is cool. No, that's not. Happy LeetCode. No, the LeetCode. No. I like it or not. Given a string, return true if it is circular. Okay. So basically for each one, we just compare to the next one. And I will compare the final one separately. Okay. Fun. Very fun. Fun problem to start with. 2490. Okay, 2490. 2490. Okay, so I in range length sentences -1 because I don't want to do the last one. I say if sentence I. Wait, hold on, dude. Need to. Split. It's a single, right? By a single space. Yeah. List. So this is the first one. So the last is equal to, actually not equal to, list I plus 1 first. If that will return false. And then we'll blah 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 blah, and then we'll return list the last one, the last thing equal to list first one, the first thing. Okay, let's see. Do we have? We do. Okay. Go. Okay, done with this. Move on. Divide players into teams of equal skills. You're given a positive integer skill of even length, where skill I denotes the skill of the ith player. Divide the player into n divided by 2. It's even, so it can always be divisible, of size 2, such that the total skill of each team is equal. What do you mean, divide the players into n divided by 2 teams of size 2? Okay, size 2. What's n divided by 2? Three teams. Oh, I see what it means. Of size 2. Okay, gotcha. The total skill of each team is equal. The chemistry of a team is equal to the product of the skills of the players on that team. Return the sum of the chemistry. So we want the sum to be equal across all teams, and we return the sum of the chemistry of all the team. Oh, okay, that's it. There's no finding maximum or minimum. So we just need to divide them and then add together their chemistry. So the first one we can do, what do you think? Sort them small to large? I mean, that's the natural way of thinking, right? Which I actually think that's the only way of thinking, because can we prove it? Well, we can say that I think we have a bunch of values, right? And we sorted them, okay? We sort the value from small to large. What we want is the sum of the two will be equal to the sum of the other two, the sum of the other two. So we look at the largest value, okay? Who the largest value going to add to? Because they all have to pair with someone. So if the largest value was not paired with the smallest value, it's paired with something else, okay? And then the smallest value cannot be paired with anybody. All right? Yeah, see, that's the proof. The largest, if largest doesn't pair with the smallest, it pair with something else, then what can the smallest pair with? The smallest cannot. If the smallest pair with the second largest, it's never going to be bigger, never going to be equal to the largest pair with the second smallest. So the largest, in order for this to work, the largest must pair with the smallest. So we're just going to go pair going in. And if any one of them fails, then we fail. Greedy. Let's try. I mean, we are not in a contest, so I don't really care if it's wrong. In fact, I think this is a risk that's worth taking. I mean, we have a proof, right? We have a proof. So we'll sort it first. And then ij equals 0, and then len skills minus 1, right? Rest equals 0. Yep. While I is smaller than j, actually rest shall equal to skill 0 times skill minus 1. Okay, and then total skill. Okay, total skill equal to skill 0 plus skill minus 1. Okay, now we can do this. That's not 0, that's 1. That's gonna be this. While this, if skill I plus skill j is not equal to total skill, return minus 1. That means it's not possible, right? Not possible. Otherwise, rest plus equal to skill I not multiplied by skill j. And I will return rest. You forgot to change I plus equal 1, j minus equal 1. All right, let's run this. I mean, we are able to run. Yeah, I mean, again, we are not doing this, so. What do you want? What I want is a random value to 1000. Okay. Let's do 100. Test equals what? For this in range 100. Okay. And then I'm gonna do randint. Holy crap. Might not work though. Might not work. It's likely that they're all gonna be minus 1. Seriously. I don't think this is gonna work. It has to be very special. Nah, man, don't think it's gonna work. Everything gonna be minus 1. All right. This shall work. That's even, yeah. Yeah, this always definitely works. Alright, let's go for it. Like we had expected, this is correct. But I don't know why it's so slow. Like, what else can you do, right? Seriously, what else can you do? Pair matching. Expected skill. Count. Oh, because you can do it on. Ha. Okay, so we find that, and then we count. Ah, I see. I see how you can do it in on. Okay, let's try on. Yep. Yeah. on. Then we don't have to, we can do counter equals, just do C, come on. Skill, all right? And then total skill shall equal to, sum skill divided by 2, right? Then we just, for everything, we are going to match, right? This match with this. Yes, rest equal to 0 for S in skill. If CS, right, if we still have, then we say if not C total skills minus S, then we'll return -1. Otherwise, rest plus equal to S times total skill minus S, and then CS minus equal 1, C total skill minus S minus equal 1. Now return rest. Yep. We did not. That's okay. It's totally fine. Did we get this one? Nope. The hell is this? We didn't get. How? Oh, that's not divided by 2, man. Divided by no, hold on. How many? So we have sum of this divided by len of this divided by 2. Divided by len skill divided by 2. There we go. That's all right. Like technically it is a win, but yeah, give me a slower runtime, which is fine. All right. We have only 12 minutes. Only one more to go. Minimum score of a path between two cities. You're given a positive integer n cities, okay? 1, 2, 3, 4. You're also given a 2D array roads, where roads I is AI, BI, distance I, indicate there is a bi-directional road between city AI, BI with a distance equal to distance I. The city's graph is not necessarily connected. Okay? The score of a path between two cities is defined. The score of a path between two cities defined as the minimum distance of a road in this path. Return the minimum possible score of a path between cities 1 and n. A path is a sequence of roads between two cities. It is allowed for a path to contain the same road multiple times, and you can visit cities 1 and n multiple times along the path. The test case is generally such that there is at least one path between 1 and n. So n is 4, so I want to find the path from 1 to 4, the minimal score is 1 to 2 to 4. score of a path between two cities is defined as the minimum distance of a road in this path. So I can go however I want, as long as I can hit the minimum, and that's good. In this case, the path from city 1 to 4 with minimal score, we go to 2 first, and in return come here, and that's 2. Ooh, no repeated edge, at least one pass. Huh. Very interesting. That's an interesting problem. So are we saying that the shortest path, if we can include, okay, so first of all, they say there got to be a path from city 1 to city n. Okay, there got to be a path. And if the minimum is on this path, then we got a minimum, right? But it is possible. It says not necessarily connected. So the minimum could be not on this path. And not on this path. But if it's connected, right? If it's connected, then it's definitely on the path. So maybe union find, right? If the two cities have a connection, we put them together. The next two cities, we put them together. Next two cities, put them together. And then, after we're done, and every time, how do we find out the... Yeah, I think that's the right path, right? So we union find, right? We union, like 1, 2, so 1, 2 become a union, and we will record the minimum path. Because when you union, right, as you union, we will take, they all belong to 1. They will all belong to 1. We can... I wanna do it in one pass. That's what I want. The minimum that's connected. I mean, we can use another. Can we do that? We union these two, right? They were pointing to that, and then we do the next, then they will point into that, and then when you union those together, we need to check. It's prone to error. I feel like it's gonna prone to error. Why don't we just, get everything in? Yeah, I think to make it easier, right? To make it easier, our union find, right? That's basically the most important thing. We union find, and then we will. That's an interesting thought. We can sort it. We can sort the roads. We sorted small to big according to the distance, and for each one we just see if they are in the union. Yep. All right, can you write union path? Man, you have 6 more minutes to write union path. Union find. I'm not sure, but we are gonna try. All right, union find. Union and find. Well, we don't call it union find. We call it DSU, disjoint. Shoot, what does this DSU stand for? I forgot. Disjoint. Dude, what does DSU stand for? Disjoint set union. Disjoint set union. Okay, so we'll have parent list range n. Okay, and we'll have rank. Rank is everybody in the 0 at the start. Okay, so now def find. We have x, right? We're gonna return an integer. How do we find? We say if self.parent x is not equal to x, right? Then self.parent x shall equal to self.find self.parent x. Is that correct?
Mm-hmm.
I am not sure. If the current if I am not my parent, then my parent, right? Then my parent should be find my parent's parent. That seems to be right. Then we return self.parent x. Okay. Now we're in the union. We're gonna union x and y, right? And now we're gonna return this. Return a Boolean value. Say if parent px and py equals self.find x and self.find y. And we say if px is equal to py, then they are already union. We return false. This doesn't really mean anything, right? We don't really use it, but it's fine. If they are different, then what do? Then we need to use, so they have a different parent. Then we need to use rank. So if rank px, if the parent of x, the rank, is larger than self.rank py, then we arbitrarily assign, we say self.parent y. So parent y instead of py, we assign it to px, right? So because they assigned to the same. Elif, we say rank px. If px is smaller than py, then we assign self.parent x. We assign it to py, and else if they are the same, then I arbitrarily say self.rank px plus equal 1. Px plus equal 1. And then we'll say self.parent y equal to px. And I'll return true. Okay, so this is my DSU. So for this, DSU equals DSU n. And for AB, I like to say XY. Let's just AB. AB and this in rows. I don't even need, right? I don't even need. I don't even need distance at the current. I just do AB and DSU.union AB. Okay. Once we're done, we'll say rows.sort key equals to lambda. That's gonna be tuple 2. Sort based on this, right? And maybe we can say for AB this in sorted, right? Sorted. If we're union. So if self.find, because 1 and 4 they definitely have, so I just need to check 1. So find 1 is equal to, we can just say if, oh no, we are changing it, we don't do it. If self.find 1 is equal to, hold on, 1, 2, that's fine. That's fine. We just need to do n plus 1. Okay. So if this is equal to self dot find a, right? If these two are equal, which means I can get to it, then I will return the distance. Okay, something like that. Okay, this one I'm not 100% sure. We already passed the time mark. But we have a solution. Just need to check if it's correct. I mean, I start with 32, so technically I still have like 2 minutes. Why you do this, man? N roads. Min score n roads. That is not correct. What the hell? Solution has no find. Oh my god. It's DSU. You're not right. Thus, nah, DSU. Yep. All right, try this. Wrong answer. Oof. Okay, this is serious. Oh, we didn't finish. 32 and 36. So we passed some, but we failed some. The hell, expected 579. Hold on. Sometimes DSU, when you do this, will have a little bit issue. It's okay. 579. It's correct. It's just we need to solve this last bit. Okay, hold on. So we want the 1 to 7, right? So 1, 3, 3, 2, 2, 4, 6, 7. That's okay. 5, 6, 4, and 5. They are all in it. So the last one, 4, 5, and 7 is not. Man, I think maybe implementation. Let's see. I think my implementation is correct. Hold on. Useful. What did we do wrong? I think we do it right, right? Event not equal to this. The smaller we'll do y. Oh, come on. It's not the first time. P. I knew it. It's not the first time I have a problem with this. It's the parent. You need to change the parent. Okay. I mean, it's in the actual competition, we just waste some time here. But overall, it's pretty good. Yeah, it's just a simple DSU. Now, if you know DSU, it's like if you union find, right? Union find everything. Then try the smallest. All right, try the smallest distance and see if it is, if its nodes are in the union of cities 1 and n. Union find is, oh, the complexity. What's that thing called? Union find complexity is the inverse of Ackermann, the inverse of Ackermann function. Whatever that is, I'm gonna ignore it. DSU, yeah, it's just DSU. DSU and the BFS. Oh, you can use BFS for this. Take minimum edge weight. Maybe DFS is easier to follow. Wait, DF, we just go from here, we go through all the things that we can get, we can reach. Oh, yeah, we just go through all the nodes we can reach. Starting from 1, because we know we'll definitely reach. So we just need to know what we can reach. Starting from 1. Ah, yeah, we don't have to use DSU actually. All right, solution number 2. BFS is easier. I'll use BFS. Just visit all the nodes that can be reached from node 1 and pick the smallest edge. Well, but we have to pre-treat. Yeah, we have to pre-treat the thing. All right, we have to pre-treat the thing. That's okay. We're gonna call graph. How big? Ten to the 5th. No. We'll go default dict. Okay. Then do what? For A, B, this in graph A dot append. I can do a tuple B this graph B dot append A this. Okay, then BFS Q equals this, res equals math.inf. Okay, then while actually Q we have to put a root as 1. While visited, right, visited equals set 1. While Q temp node in queue. Right, and then for next node in graph, next node this in graph, A, B in graph A. If B is not in visited, right, then temp.append B, visited.add B. That's my habit of doing this. Res equals minimum, res and this. Return res. Let's see if this one's correct. Oh, shoot. My bad. Forgot to swap. That is not fair. What? How? Oh, something is not right. Wait, what? What's the graph? Did we screw up graph? Oh my god. Ooh, that is not how I expect it to be. Really? One, baba. Go do this, right? Then 4. Oh, 4 need to go to this one. Oh, it's not as straightforward. What do we do? Edges. If an edge has been visited. If an edge has been visited. Okay. If AB is not in AB. Yeah. Record visited edges. Might be faster actually. No. Timeout. Oh, lordy. This one times out. Oh, wow. Huh. Then how do these pass? Unless they do it better. Hold on. Well, it's basically my way of doing it is not right. Yeah, send timeout. Oh, we have to check on the cycles. Huh. I see. But DFS doesn't have this, right? DFS doesn't have it. BFS, I see. It's going, but I have set up so the same edge will not be visited. What if and BA not being visited? Right? We can do that. Still works here. Will this work? Maybe. Yeah, well, it works. Has to check both edges. The visited has to check on edges, and each edge only, and since we only want to visit each edge once, we have to put both AB and BA as edges when this into the visited set when either of them is visited, is encountered. So number of edges. Let me say how many is number of edges. Distances. I mean, this is all roads, right? And this is, we're visiting each edge, because each edge is only visited once. So the edge is ON plus M, right? ON plus M, where N equal to length roads. No, we have N. I don't know. I think it's the roads. I don't call it OM. I think it's just M. I don't think it has anything to do with... That's my understanding. But it's apparently slower. Anyway, so... Yeah, let's do this again tomorrow with the DFS. Alright, that will be it for today.